Hello everyone, let us solve problems on primal to dual. Suppose given sum is like this, write the dual of the following. This is question number 1. Objective function is maximize z is equal to x1 plus 2x2 plus 3x3 subject to these constraints 2x1 minus x2 plus 3x3 less than or equal to 2, x1 plus x2 is equal to 3 minus x2 plus x3 greater than or equal to 5, x3 less than or equal to minus 3, and here x1 x2 greater than or equal to 0, x3 is unrestricted. Such type of primal is given, that means given sum is primal, and we have to find out its dual. You have to concentrate on this objective function. This is maximized type, and its dual will be minimized type. Here maximize z, dual will be minimize w. Okay, minimize w, new variable. So in case of maximized type, constraints must contain less than or equal to inequality, like this, less than or equal to inequality or is equal to. But here in third constraint there is greater than or equal to inequality. So in this third constraint, multiply this constraint by -1, then automatically this inequality becomes less than or equal to, and sign coefficients of variables on left hand side and constant term on right hand side, their signs will change. Okay, then you have to concentrate on these restrictions like x1 x2 greater than or equal to 0 and x3 is unrestricted. Here in primal problem, third variable is unrestricted and second constraint is an equation, means which is having equal to sign. This is having equal to sign. Okay, now this equal to sign in constraint, this implies second variable in dual that will be unrestricted, like this. This is x3 is unrestricted, but in dual y2 will be unrestricted. Okay, if we consider new variables in dual y1 y2 y3 something, then y2 will be unrestricted, and in primal x3 is unrestricted, variable x3 is unrestricted. Meaning of this is third constraint in dual must be having equal to sign. Okay, remember maximize to minimize z to w, then maximize, in case of maximized type, inequalities must be less than or equal to in constraints, and if any one variable is unrestricted in primal, then constraint just like this, x3 is unrestricted means third constraint in dual will be having equal to sign, and here in primal this second constraint is with equal to sign. Meaning of this is second variable in dual that will be unrestricted. Okay, first of all express this primal problem in tabular form like this. Maximize z, here also maximize z. What are the coefficients of x1 x2 x3 in objective function? 1 2 3, put here 1 2 3 like this. Okay, we are putting coefficients of x1 x2 x3 from objective function like this 1 2 3. Okay, then variables x1 x2 x3, variables x1 x2 x3, below 1 x1, below 2 x2, below 3 x3, which represents 1 is coefficient of x1, 2 is coefficient of x2, and 3 is coefficient of x3 in objective function of maximization type. Okay, then draw a horizontal line and vertical line to write the constraints. Here below this line, what we have to do, coefficients of x1 from first column, that will be 2 1. Here x1 is not present in third constraint, so coefficient of x1 will be 0. So 2 1 0, that will be 2 1 0, and there is one more constraint, fourth constraint. Here x1 and x2 are not there, So 0x1 plus 0x2 you can assume. So 2 1 0 0 2 1 0 0. Below x2, coefficients of x2 from constraints -1 plus 1 -1 0 -1 plus 1. Here this is greater than or equal to sign. We are multiplying by -1 on both sides. So -1 into minus, that becomes +1, and this 0. Then third constraint, that is uh, coefficients of x3 from this constraint 3 0 1 1 3 0. This is 1, but we are multiplying by -1, so -1 3 0 -1 1. Okay, these are coefficients of x1 x2 x3 from constraints. And now inequalities, this is maximization type. So inequality, which inequality is required? Less than or equal to 2, keeping this as it is. This is equal to, keeping this as it is. We are changing this inequality to less than or equal to, multiplying by -1. So this can be written as less than or equal to, sign of 5 will change, that becomes -5. And then fourth constraint, that is 0x1 plus 0x2 plus 1x3 less than or equal to -3, less than or equal to -3, keep this as it is. On right hand side there is minus sign, but doesn't matter, don't do any change on right hand side of this fourth constraint, keep this as it is. So 0 0 1 less than or equal to -3, because this is maximization type problem. So all constraints must be either less than or equal to or equal to. Then x1 x2 greater than or equal to 0, x3 is unrestricted. Here also, in this format also, x1 x2 greater than or equal to 0, x3 is unrestricted. By using this format, this is tabular form of given primal. By using this format, we have to obtain tabular form for dual of given primal. So what we have to do? First of all, these are constant terms which are appearing on right hand side, put here, okay, which are coefficients of x, new variables y1 y2 y3 y4 in objective function, minimization type of objective function with new variable w. So w is equal to 2y1 plus 3y2 minus 5y3 minus 3y4. You are taking these constant terms here as the coefficients of new variables y1 y2 y3 y4 for objective function w. Okay, then below these constant terms put y1 y2 y3 y4 like this, variables. Draw a horizontal line, then vertical line, and then what we have to do? First of all, concentrate here, x3 is unrestricted, means in this third constraint must be with equal to sign. Third constraint, this is third constraint, it must be equal to with equal to sign, must be equation. So is equal to, this is what, -3, 1 2 3, these numbers we have to take here, 1 2 3 with proper sign. Minimization type means greater than or equal to sign, okay. But here third constraint in primal is unrestricted, so third variable is unrestricted, so third constraint must be with equal to sign, 1 2 3, these 1 2 3 here and these numbers here, okay. Then we have to change the position, means like transpose of given matrix, okay. First column becomes first row, second column becomes second row, third column becomes third row. First column is 2 1 0 0, that becomes first row, 2 1 0 0. Second column is -1 1 1 0, so second row of dual is -1 1 1 0. Third column of primal is 3 0 -1 1. Then third row of dual, that will be 3 0 -1 1, okay. And here second constraint is with equal to sign, meaning of this y2 means second variable of dual, that will be unrestricted, and here x3 is unrestricted, means third constant is with equal to sign. Okay, this is tabular form of dual form. And now we have to taking multiplication, put this in standard form like this. Solution of this: minimize new variable w, which is objective function, is equal to 2y1 plus 3y2 minus 5y3 minus 3y4. Okay, subject to these are coefficients of constants. 2y1, first constant 2y1 plus 1y2 plus 0y3 plus 0y4 greater than or equal to 1. Second constant minus 1y1 plus 1y2 plus 1y3 plus 0y4 greater than or equal to 2. This is dual. Then 3y1 plus 0y2 minus 1y3 plus 1y4 is equal to 3. y1, y3, y4, these are greater than or equal to 0 variables, and y2 is unrestricted because of this equal to sign, second constraint equal to sign. Second constraint is having equal to sign, so second variable in dual, that will be unrestricted. This is unrestricted, and this is dual of given primal. Given primal is in terms of maximization type. Given primal is maximized and dual will be minimized. Let us solve one more sum where primal is in terms of minimized type. Let us solve this one. Write the dual of the following problem. Here we are considering minimize previous sum, just previous sum. Whatever may be dual we have obtained in sum number 1, that we are considering as primal for second sum, and we are getting dual of this, that will be previous sum, primal of sum number 1. Okay, now here problem is like this. Write the dual of the following problem. Minimize, here minimize w is equal to 2y1 plus 3y2 minus 5y3 minus 3y4. Objective function is w. Okay, and subject to these constraints. How many constraints are there? 3. And these are conditions: y1, y3, y4 greater than or equal to 0. y2 is unrestricted. Now what we have to do? This is minimization type, so we want greater than or equal to inequality in each and every constraint, greater than or equal to inequality or equal to sign. So first constraint, that is already greater than or equal to, and second constraint is also with greater than or equal to inequality. Third constraint is with equal to inequality, equal to sign, means third constraint is equation. Okay, so no need to change the inequalities from any constraint, because minimization type required greater than or equal to inequality or equal to sign. Here already required inequalities are there. Now concentrate on unrestricted variable. This is y2, second variable. y2 is unrestricted. Meaning of this is very simple. This is variable, but in dual second constraint must be having equal to sign. इसका मीनिंग सिंपल है. यहाँ पे वेरिएबल y2 अनरेस्ट्रिक्टेड है, लेकिन ड्यूअल में क्या होता है, सेकंड कंस्ट्रेंट इक्वल टू साइन के साथ आता है. और फिर यहाँ पे हम ये करेंगे थर्ड कंस्ट्रेंट. देखो, इन थर्ड कंस्ट्रेंट देर इज इक्वल टू साइन, एंड मीनिंग ऑफ दिस इज व्हाट, कंस्ट्रेंट नंबर 3 मीन्स थर्ड वेरिएबल ऑफ ड्यूअल, दैट विल बी अनरेस्ट्रिक्टेड. ओके, थर्ड वेरिएबल ऑफ ड्यूअल विल बी अनरेस्ट्रिक्टेड. अनरेस्ट्रिक्टेड से कंस्ट्रेंट में चेंज होता है, अनरेस्ट्रिक्टेड वेरिएबल से, और इक्वल टू साइन वाले कंस्ट्रेंट से वेरिएबल में चेंज आता है, वेरिएबल अनरेस्ट्रिक्टेड बनता है. ओके, नाउ इट्स टेबुलर फॉर्म. दिस इज टेबल. मिनिमाइज w, coefficients of y1, y2, y3, y4. These are given variables. This problem is in terms of variables y1, y2, y3, y4. So coefficients are 2, 3, minus 5, minus 3. Put here 2, 3, minus 5, minus 3. These are coefficients of y1, y2, y3, y4. Okay, if we take multiplication 2y1 plus 3y2 minus 5y3 minus 3y4, that becomes objective function of this minimization type, and then draw horizontal line and vertical line to make such type of figure. And under this line, under this horizontal line, we have to put the coefficients of y1, y2, y3, y4 from constraints. First of all, coefficients of y1 from constraint. Coefficients of y1 are 2, minus 1, 3. Put here 2, minus 1, 3. Then coefficients of y2 from constraints 1, 1, 0. 1, 1, 0. Because y2 is not there in third constraint. Then coefficients of y3. In first constraint, y3 is not there, so you can write like this, 0 times y3. Then coefficient of y3 is 0. So third column, that will be 0, 1, minus 1, 0, 1, minus 1. And then fourth variable, that is y4, its coefficients are 0, 0, 1, because in first constraint y4 is not there. In second constraint also y4 is not there. So 0 y4, 0 into y4, 0 into y4, you have to add in first constraint and in second constraint. So coefficients of y4 will be 0, 0, 1, 0, 0, 1. Okay. Then now constraint number second, that will be with, it is in dual, and here as it is greater than or equal to 1, greater than or equal to 1, greater than or equal to 2, greater than or equal to 2, is equal to 3, is equal to 3. Here y1, y3, y4 greater than or equal to 0, means this is tabular form of this one. So everything will be same, only changing the required inequalities. Okay, y1, y3, y4 greater than or equal to 0, and y2 is unrestricted. Now tabular form of dual, by using this tabular form, what we have to do, this is minimize w. So in dual form, maximize z. Now new variables, that will be x1, x2, x3. Number of variables depends upon constant appearing on right hand side of these constraints. 1, 2, 3, put here 1, 2, 3. That will be coefficients of new variables in objective function. There are 3 values, 1, 2, 3. So 3 variables, x1, x2, x3. Then maximize z is equal to, objective function becomes maximize z is equal to 1 times x1 plus 2 times x2 plus 3 times x3. Okay, so 3 times x3, 1, 2, 3 we have to put here, and these 2, 3, minus 5, minus 3, where we have to put here 2, 3, minus 5, minus 3 we have to put here. Now this, just like transpose, we have to take transpose of this, just like matrices type. First column 2, minus 1, 3, that becomes first row of dual. 2, minus 1, 3, 1, 1, 0, second column, second row here 1, 1, 0, third column here third row, fourth column here fourth row, 0, 0, 1, 0, 0, 1. Now this is maximization type, so inequality must be less than or equal to, either less than or equal to or equal to sign. But equal to sign, where we have to put equal to sign? Here y2 is unrestricted. In primal, y2 is unrestricted, means second constraint will be with equal to sign. In dual form, second constraint will be with equal to sign. And here third constraint is with equal to sign in primal. So in dual, meaning of this, third variable of dual, that will be unrestricted. Third constraint, third variable. Second variable, second constraint. Okay, this is tabular form of dual, using this tabular form. Now write it in standard form. So solution, that will be, given sum is minimize types. So from this table, maximize z is equal to 1x1 plus 2x2 plus 3x3. This is objective function. Okay, then subject to constraints, subject to first constraint, that will be 2x1 minus x2 plus 3x3 less than or equal to 2, like this. Second constraint will be 1x1 plus 1x2 plus 0x3 is equal to 3. This is second constraint. Then third constraint of dual, that will be 0x1 plus 1x2 minus 1x3 less than or equal to minus 5. Okay, 0x1 plus 1x2 minus 1x3 less than or equal to minus 5. And fourth constraint, that will be 0x1 plus 0x2 plus 1x3 less than or equal to minus 3. Okay, and then these are restrictions. x1 x2 must be greater than or equal to 0, and x3 is unrestricted. x3 unrestricted, that is we obtained from this, where from third constraint. And y2 unrestricted means second constraint in dual, that will be with equal to sign. In this way you have to convert primal to dual. So here we have solved two sums on primal to dual. Thank you all. Thanks.